This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level Mathematics Revision. In this video I'm looking at the AQA D2 specification, and it's question 2 from the June 2010 paper. This question shows us about 5 students and 5 different games and the penalty points given for mistakes that they made. So we've got the penalty points incurred by 5 students in 5 different games, and we're asked to use a Hungarian algorithm for each of the 5 students is to be allocated to a different game, so the total number of penalty points is minimized. In other words, minimize the values in this table that when we make an allocation. We're asked to do that by reducing the rows first and then the columns, and show that we get this new table where we have to find the value of k. The question then carries on and asks us to show that we can cover the zeros in 3 lines, and asks us to continue using the algorithm to augment the table to the point where we need 5 lines are required to cover the zeros. And it says, hence find possible ways of allocating the students to the games with the minimum number of points, and for us to actually state what that minimum is. In other words, to go through and complete the algorithm for this particular table of values. So, starting off then with our table, and we were asked to reduce the rows first. So by reducing rows, we were subtracting the smallest amount from each of the rows. So the first row would be 3, second row 4, the next row 1, and then 3, and finally 4, so that we end up with the following, taking 3 from the first row: 2, 4, 0, 5, and 5, taking 4 from the next one: 4, 2, 0, 4, and 3, 1 from the next one: 5, 0, 1, 9, and 2, and then 3 from the next one: 1, 1, 0, 7, 4, and finally subtracting 4 from that final row gives us 0, 2, 0, 3, and 5. So that's what we call the row reduction. And then we need to do column reduction in a similar way, so subtracting the smallest amount for the columns. Now a lot of these have got zeros in them, so the first 3 columns are all of zeros, so we can simply copy those columns across: 2, 4, 5, 1, 0, 4, 2, 0, 1, 2, 0, 0, 1, 0, 0. Now the next column, the smallest value is 3, so subtracting that gives 2, 1, 6, 4, 0, and finally subtracting 2 from the last column gives 3, 1, 0, 2, and 3. So there's our column reduction completed. The marking at that stage then was to give a method mark for the row reduction, a method mark, and a mark for the column reduction. The value of k had to be stated, so k was in the row 3 and column 4, which is that one there. So we needed to state that k was equal to 6. Now that's the table that we started with at the top, so I'll just superimpose over that the one that we've just found, and then we can carry on with the rest of the question. We're asked to show then that we can cover the zeros that we found by 3 lines. And if we do that, well, if we take this column here, cover that one, all of those zeros are covered. There's then 2 rows required. One for cat's row there, and one through L there. The smallest uncovered value is now equal to 1. So if we can therefore augment the table. So the smallest uncovered is equal to 1. And so we can augment by that. We add to each of the intersection points. So we're adding to this point and this point that value 1, and subtracting from all of those where there's no line at all. So we'll be subtracting from all of these values here that value 1. Now there's no need to do any explanation, but simply go through and do that, so that the result that we get, taking that top row first of all, it becomes 1, and I missed out 2 negatives there, so 4 minus 1 is 3. The 0 doesn't change, then 1 and 2. And the next row, subtracting 3, again, there should be a subtraction there, 1, no change with the 0, 0 and 0. The next row doesn't change apart from the intersection of the lines, so it's 5, 0, and at that intersection it's increased by 1, so that becomes 2, the 6 and the 0 remaining the same. The next row again we're subtracting, so we get 2 zeros. There's no change of the next 0, and then subtracting again 3 and 1. Then again in the final row, no change to start off with, but we're adding 1 at the intersection, and then no change after that. Now we can now see then that we now need 5 lines, because every single row has got a 0 in it, and at least 1 0, and every single column has a 0 in there. So we now need 5 lines. And it says find the possible number of ways of allocating the students to the 5 games with the minimum total penalty points. Well, clearly, if we look at the top row, then Ali must be allocated game 3, which is where the 0 is in that row. So that is 1 0. Once we've done that, if we look at the other rows and columns, we've now got some choices that we can take. So let's allocate Beth first of all to, let's say, game 4. And that means that for game 5, it must be Kat that's doing that. And if we then look at the Di and Ellie, well, if we first of all look at Elle rather, you can see that the game 4 has been taken up there, so she would have to do game 1, and Di therefore is doing game 2. So that allocation there, let me just write that out, is A is doing 3, Beth doing 4, Kat 5, Di 1, and L, sorry, beg your pardon, Di 2 and L 1. There is an alternative to that, so let me just get a different colour for my highlighting pen. We still have Ali needing to do game 3 there, but there was this alternative then that Beth does game 5, and that means that Kat must do game 2. Once we've got cat doing game 2, then we're left with die doing 1 and L doing 4. So that's the other alternative that we could have had. So writing that one out, we have A3, B is doing 5, C2, D1 and E4. Now if you go back to the original table, which I'll bring up in a second, we'll be able to count from that the minimum penalties that we have. Well, let's use the first allocation that we got, which was here A3, B4, C5, D2 and L doing 1. We can see from that then that we get a minimum value in total of 22. Now the marking for this was as follows. There was a method mark for using this uncovered value equal to 1, an A mark for producing the new table, and then a method mark and A marks for each of these. The method mark was we're getting A3 must be the allocation there, and then an answer mark for each of these other values. The minimum value was then given a B1 mark. Okay, that's the end of this particular question. Videos of other questions can be found at www.furthermaths.org.uk.